All right, 8th graders, welcome to Unit 3 already. Today we're going to be going over Lesson 2, Dilations. So just as a reminder, transformation means changes to a shape or repositions a point, line, or figure. Okay, so it can change a shape or just reposition it. All right, so today we're going to talk about a specific type of transformation, one that we haven't done yet. So far we've only focused on repositioning them. Today we're going to actually focus on changing the size, okay? So, which is dilation, which is a type of transformation that enlarges or reduces a figure and repositions a point, line, or figure based on a specific scale factor. So, sounds big and fancy. Really, it's just multiplying and dividing, okay? So, couple things to keep in mind, and I would screenshot this, write it down, whatever you want to do to make sure that you remember. But this is really important. This is really important. If the scale factor is greater than 1, your new line segment or figure will be larger. If the scale factor is between 0 and 1, the dilated segment or figure will be smaller. Okay? So if you are multiplying by a number that is bigger than 1, you're going to get a bigger thing. If you're multiplying by a number that's smaller than 1, you're going to get a smaller thing. So enlarging, shrinking. Number 1 comes from your practice in our examples. Line segment AB has endpoints A, -6, 4, and B, -8, 2. Find the coordinates of A prime and B prime after a dilation with a scale factor of 1/2 centered at the origin. So with this, all you're going to do is you are going to take those points. So we have A, -6, 4, B, -8, 2, and we're going to be multiplying those by 1/2. That's all we're doing. So with that, we could say -6 times 1/2, 4 times 1/2, and then -8 times 1/2, and 2 times 1/2. So, and when you're multiplying by a half, you're taking half of something, or you're dividing by 2. So thankfully, all of these numbers are really easy to divide by 2, but that's really the action that you're doing, or you could multiply by a half in your calculator as well, and that would be fine. So in this case, for A prime, we can say -6 times 1/2, well that's equal to -3. And then 4 times a half, or half of 4, is 2. So there's A prime. For B prime, we're going to do the same thing. -8 times 1/2 gets us to -4. And then 2 times 1/2 is equal to 1. So this would be your final answer. Those are the endpoints of your new line segment. Okay? And if you were to graph it, you would see that this is like half of the size as the first line. With this second example, it says determine the scale factor used in the dilation of line segment AB centered at the origin. So here's this one. We're given A prime, B prime, right, the new line segment, and we're supposed to determine the scale factor. On the problem before this, we were already given the scale factor and used it to find the second line. This one, we're looking for the scale factor. So with that, what we can do is we can list, let's see, we've got A, which is at 0.23, and A prime, which is at 0.69. What we can think to ourselves is, how did we get from 2 to 6? How did we get from 3 to 9? Well, with both of those, you could multiply by 3. So let's check to make sure that the same is true for B and B prime. So we've got B at 4, 1. B prime is at 12, 3. Well, to get from 4 to 12, multiply by 3. To get from 1 to 3, I'd multiply by 3. So it is a scale factor of 3. Okay, so this line is 3 times the size of this line. And notice we had a scale factor that's larger than 3, and we went from a smaller line to a bigger line. Okay, last example for today, number 2 on your quick check. Select the coordinates A prime and B prime after dilation of the line segment AB with a scale factor of 1/3 centered at the origin, where the endpoints are A, -6,3, and B, -12,9. So this is just like number 1 that we did, or the first example that we did earlier. So we could take our original points, which in this case are A, -6,3, B, -12,9, and then our scale factor is 1/3. So in order to get A prime and B prime, we need to multiply each of our coordinates by 1/3, which again, at least in this case, the numbers that they gave us, they work well with 1/3. Okay, so multiplying by 1/3 is the same thing as dividing by 3. So -6 divided by 3 to get us A prime, that's going to be -2. And then 3 times 1/3 is 1. You could also do that on your calculator, I don't mind. And then for B prime, -12 times 1/3, or -12 divided by 3, gives us -4. And then 9 times 1/3 is 3. So this right here, this would be your final answer that you're going to look for in the multiple choice answers. Okay? So as always, if you need extra support, let me know. I'm happy to help.